Good afternoon, all of you. I am Ramesh and welcome to today's session. In last class, we discussed about the concept of charge, method of charging, and today's class we will discuss about what is the force of attraction or repulsion between two charged bodies or two charged particles. We know that any two charged particles may attract or repel each other based on the polarity of the charge. Okay. Now then, how to find out the force of attraction or repulsion between the charged bodies? How to calculate the force of attraction or repulsion between the any two charged particles is using a law called Coulomb's law for electrostatics. This law will help us to find out the force of attraction between the charged particles or force of repulsion between the charged particles. So let us have a look at the statement of Coulomb's law. Coulomb's law says that the force between two point charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between them. The direction of this force is along the line joining the two charges. Okay. The Coulomb's law, what it says is the force of attraction or repulsion between any two charged particles or charged bodies is that force is directly proportional to the product of magnitude of charges. Okay. If the magnitude of charges, let it be Q1 and Q2, then the force of attraction or repulsion is directly proportional to the product of magnitudes, that is Q1 into Q2. Similarly, it is inversely proportional to the square of the distance between them. If the distance between both the bodies or both the charged particles are r, then it is inversely proportional to the square of the distance between them. So mathematically, Coulomb's law can be written like this. Okay, you can observe here in the equation. You can observe here. Okay, from the Coulomb's law, mathematically, this force of attraction or repulsion between two charged bodies is directly proportional to the product of the magnitude of the charge and inversely proportional to the square of the distance between them, which is r square. Now, if you remove the proportionality sign, you will get a proportionality constant. That constant can be replaced by 1 by 4 pi epsilon naught. Okay. In the term 1 by 4 pi epsilon naught is the absolute permittivity of a free space. Okay, this is the Coulomb's law for electrostatics, or this Coulomb's law will help us to find out the force of attraction or repulsion between any two charged bodies or any two charged particles. Okay, let us move ahead. Now let us try to write this Coulomb's law in a vector form. Very simple it is. So vector F, which is force of attraction or repulsion between any two charged bodies, is written like this. Okay, vector F is equal to 1 by 4 pi epsilon naught, which is constant. You can put as it is. Then product Q1 into Q2 by r square. You can observe here in the vector form. Okay, so this r cap is nothing but the unit vector which is in the direction of force F, which is electrostatic force. So this is the vector form of electrostatic force between, or Coulomb's force between any two given charged bodies. Now we know that Coulomb is the SI unit to measure the charge. Okay, Coulomb is the SI unit we will use to measure the charge. So the symbol we will use is C. Then one more thing you can observe here. Now we know that Coulomb is the definition, Coulomb is the charge, or Coulomb is the unit to measure the charge. Now how to define the Coulomb then? What is the meaning of Coulomb? When you call that the body is having 1 Coulomb of charge, so that we need to define, or that can be defined using this formula, that is electrostatic force between any two charged bodies. So this equation we got from the Coulomb's law, in the previous slide only we got this equation, which is F equal to 1 by 4 pi epsilon naught Q1 into Q2 by R square. So that equation can be rewritten as F equal to 9 into 9 into 10 to the power 9 into Q1 into Q2 by R square. So this 1 by 4 pi epsilon naught can be replaced by 9 into 10 to the power 9 value, okay, that constant. Now in this equation, in the considered equation, let us put Q1 equal to Q2, which is 1 coulomb, and also we can put R equal to 1 meter. So if you put these two values in this considered equation, then force F is equal to 9 into 10 to the power 9, because Q1 and Q2 becomes 1 here and R is also 1, then F becomes 9 into 10 to the power 9. So F is equal to 9 into 10 to the power 9 Newton. So from this relation we can define the Coulomb. So let us see how we can define. 1 Coulomb is the charge which repels another identical charge with a force of 9 into 10 to the power 9 Newton. So when placed at a distance of 1 meter in a free space. I will repeat here. 1 Coulomb is the charge. If you want to call that a body is charged by 1 Coulomb, then the force of attraction or repulsion between the two charged body or particles which are having 1 Coulomb each charge, then the force of attraction or repulsion between them should be 9 into 10 to the power 9 Newton when the distance between them is 1 meter. ಸಿಂಪಲ್ ಆಗಿ ಹೇಳಬೇಕಂದ್ರೆ 1 ಕೂಲಂಬ್ ಚಾರ್ಜ್ ಅಂತ ಯಾವುದಕ್ಕೆ ಕರಿತೀವಿ ಅಂದರೆ, ಎರಡು ಚಾರ್ಜರ್ ಪಾರ್ಟಿಕಲ್ ತೊಗೊತೀವಿ ಅಂತ ಅಂದ್ಕೊಳ್ರಿ. ಓಕೆ, ಚಾರ್ಜರ್ ಪಾರ್ಟಿಕಲ್ 1 ಆ್ಯಂಡ್ ಚಾರ್ಜರ್ ಪಾರ್ಟಿಕಲ್ 2. ಓಕೆ, ಚಾರ್ಜರ್ ಪಾರ್ಟಿಕಲ್ 1 ಮೇಲೆ ಇರುವಂಥ ಚಾರ್ಜ್ ಏನಾಗಿದೆ 1 ಕೂಲಂಬ್ ಅಂತ ತೊಗೊಳ್ರಿ. 2 ಮೇಲಿರುವಂಥ ಚಾರ್ಜು ಕೂಡ 1 ಕೂಲಂಬು. ದೆನ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ 1 ಮೀಟರ್ ಇರಬೇಕು. ಓಕೆ, ಯಾವುದೇ ಎರಡು ಚಾರ್ಜರ್ ಪಾರ್ಟಿಕಲ್ನ ತೊಗೊಳ್ರಿ. 1 ಕೂಲಂಬ್ ಚಾರ್ಜ್ ಇರುವಂಥ ಎರಡು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ನ ತೊಗೊಳ್ರಿ. ಅವೆರಡನ್ನು 1 ಮೀಟ್ರ್ ದೂರದಲ್ಲಿಟ್ಟಾಗ ಅದರ ಮಧ್ಯದಲ್ಲಿರುವಂಥ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ರಿಪಲ್ಷನ್ ಎಷ್ಟಿರುತ್ತೆ ಅಂದರೆ 9 into 10. ಓಕೆ, ಸಿಂಪಲಾಗಿ ಹೇಳ್ತೀನಿ, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ. 1 ಕೂಲಂಬ್ ಚಾರ್ಜ್ ಅಂತ ಯಾವಾಗ ಕರಿತೀವಿ ಅಂದರೆ, ಓಕೆ, ಲೆಟ್ ಅಸ್ ಟೇಕ್ ದಿಸ್. ಓಕೆ, 1 ಕೂಲಂಬ್ ಚಾರ್ಜು ಅಂತ ಯಾವಾಗ ಕರಿತೀವಿ ಅಂದರೆ ಅಥವಾ ಯಾವುದೇ ಬಾಡಿ ಮೇಲೆ ಇರುವಂಥ ಚಾರ್ಜ್ 1 ಕೂಲಂಬ್ ಯಾವಾಗ ಆಗಿರುತ್ತೆ ಅಂದರೆ, ಎರಡು ಚಾರ್ಜ್ ಬಾಡಿನ ತೊಗೊಳ್ರಿ ಅಥವಾ ಚಾರ್ಜರ್ ಪಾರ್ಟಿಕಲ್ನ ತೊಗೊಳ್ರಿ. ಎರಡರದ್ದು ಚಾರ್ಜು 1 ಕೂಲಂಬ್ ಆಗಿರಬೇಕು. ಓಕೆ, ಎರಡು ಚಾರ್ಜರ್ ಪಾರ್ಟಿಕಲ್ ಅವ್ರ ಚಾರ್ಜ್ ಬಾಡಿ ತೊಗೊಂಡಿದ್ದೀನಿ, ಎರಡರ ಮೇಲಿನ ಚಾರ್ಜು 1 ಕೂಲಂಬ್ ಆಗಿದೆ. ಅವೆರಡನ್ನ 1 ಮೀಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ದೂರದಲ್ಲಿ ಇಡ್ರಿ. ಓಕೆ, ಎರಡು ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ನ ತೊಗೊಂಡಿದ್ದೀನಿ, ಎರಡರ ಮಧ್ಯದಲ್ಲಿರುವಂಥ ಡಿಸ್ಟೆನ್ಸು 1 ಮೀಟರ್ ಆಗಿದೆ. ಎರಡೂ ಬಾಡಿ ಮೇಲಿರುವಂಥ ಚಾರ್ಜ್ ಕೂಡ 1 ಕೂಲಂಬ್ ಆಗಿದೆ. ಈ ಥರ 1 ಮೀಟರ್ ದೂರದಲ್ಲಿ ಇಟ್ಟಾಗ 1 ಕೂಲಂಬ್ ಚಾರ್ಜನ್ನ, ದೆನ್ ಎರಡರ ಮಧ್ಯದಲ್ಲಿರುವಂಥ ಫೋರ್ಸ್ ಎಷ್ಟಾಗಿರುತ್ತೆ ಅಂದರೆ 9 into 10 to the power 9 Newton ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ವಾಟ್ ದಿ ಕಾನ್ಸೆಪ್ಟ್ ಬಿಹೈಂಡ್ ದಿ ಡೆಫಿನಿಷನ್ ಆಫ್ ಕೂಲಂಬ್. ಸೊ ಈ ಥರ ಇದ್ದಂಥ ಚಾರ್ಜಿಗೆ ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು, 9 into 10 to the power 9 ನ್ಯೂಟನ್ ಫೋರ್ಸ್ ಇರುವಂಥ ಚಾರ್ಜನ್ನು 1 ಕೂಲಂಬ್ ಚಾರ್ಜ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ದ್ಯಾಟ್ ಐ ಕ್ಯಾನ್ ಟೆಲ್ ಇಟ್ ಇನ್ ಇಂಗ್ಲೀಷ್ ಆಸ್ 1 ಕೂಲಂಬ್ ಇಸ್ ದ ಚಾರ್ಜ್ which repels another identical charge with a force of 9 into 10 to the power 9 Newton when placed at a distance of 1 meter in a free space. ಓಕೆ, ಯಾವುದೇ ಒಂದು ಬಾಡಿ ಮೇಲಂಥ ಚಾರ್ಜ್ 1 ಕೂಲಂಬ್ ಅಂತ ಕರಿಬೇಕಂದ್ರೆ ಆ ಎರಡು ಬಾಡಿ ಮಧ್ಯದಲ್ಲಿರುವಂಥ ಫೋರ್ಸು 9 into 10 to the power Newton ಆಗಿರಬೇಕು. ಯಾವಾಗಂದ್ರೆ ಅವೆರಡರ ಮಧ್ಯದಲ್ಲಿರುವಂಥ ಡಿಸ್ಟೆನ್ಸು 1 ಮೀಟರ್ ಆಗಿರುತ್ತೆ. ದೆನ್ ಯೂಸಿಂಗ್ ದಿಸ್ ರಿಲೇಷನ್ ವಿ ಕ್ಯಾನ್ ಡಿಫೈನ್ ಡೆಫಿನಿಷನ್ ಫಾರ್ ಕೂಲಂಬ್. ಓಕೆ, ಸೊ ಲೆಟ್ ಅಸ್ ಮೂವ್ ಅಹೆಡ್. We know the formula, which is F equal to K into Q1 into Q2 by R square. Let us call this equation as 1. Okay, this equation already we got it from the Coulomb's law. So instead of writing 1 by 4 pi epsilon naught, I have written it as K. Now when charges are placed in a free space or air or vacuum, then value of K is nothing but 1 by 4 pi epsilon naught. If the charged particles are kept in a free space or air or vacuum, then its K value will be 9 into 10 to the power 9 Newton meter square per Coulomb square, the value of constant K, where epsilon naught, I repeat once again, where epsilon naught is the absolute permittivity of free space its value is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Now then equation 1 becomes 9 into 10 to the power 9 into Q1 by Q2 divided by R square. When charges are placed in a dielectric medium other than free space. Okay, so this expression when you will get is, you will get this expression when the charge body or charged particle is kept in a free space or vacuum or air. Instead of free space, if you keep the charge particle in a dielectric medium or other than the free space ಅಲ್ಲದೆ ಯಾವುದಾದ್ರೂ ಬೇರೆ ಮೀಡಿಯಮಲ್ಲಿ ಇಟ್ಟಾಗ then value of k equal to 1 by 4 pi into epsilon naught. ಇಲ್ಲಿ epsilon naught ತಗೊಳ್ಳಿಲ್ಲ ನಾನು, only epsilon. Epsilon ಅಂದರೆ it is absolute permittivity of the medium, because in first case we kept a charge in a free space or air, that is why I have considered epsilon naught, which is the absolute permittivity of a free space. Now instead of epsilon naught I have taken it as epsilon, 1 by 4 pi epsilon. Epsilon is the absolute permittivity of a medium where you kept the charge. Now let us move ahead to the next slide. Now permittivity of a medium. How do you define permittivity of a medium? Permittivity is the ability of the medium. I repeat, permittivity is the ability of the medium to allow electric field lines pass through it. Okay, permittivity ಅನ್ನೋದು ಪ್ರಾಪರ್ಟಿ ಆಫ್ ದ ಮೀಡಿಯಮ್ ಅದು. ಸೊ ದ್ಯಾಟ್ ಪ್ರಾಪರ್ಟಿ ವಿಲ್ ಡಿಸೈಡ್ ದಿ passage of electric fields or passage of electric field lines to pass through the medium. Okay, then permittivity is defined only for dielectric, which are insulators. Now relative permittivity or dielectric constant, so which I can call it as epsilon or simply k. Consider how to define relative permittivity. Then consider two charges q1 and q2 which are placed in free space. Free space means which is air or vacuum, and which are separated by a distance r. Then according to Coulomb's law we can have this. Okay, according to Coulomb's law we can have this relation. Which one? Okay, this one. This according to Coulomb's law we can have this equation, right? 1 by epsilon naught q1 by q2 by r square. So when you will consider this equation, when the charged particle is kept at a free space or kept in a free space means air or vacuum. So instead of free space, if the charged particles are placed in a dielectric medium, other dielectric medium means medium other than the free space you can consider, then the formula or the from Coulomb's law takes the form of Fm equal to 1 by 4 pi epsilon into q1 into q2 by r square. This formula electrostatic force Fa is applicable when the charged particles are kept in a free space. This formula is applicable when the charged particles are kept in a dielectric medium. Dielectric medium in the medium other than the free space you can consider. If you take the ratio of equation 1 and equation 2, and you can get this expression Fa by Fm, which is equal to epsilon by epsilon naught into which is equal to epsilon r. Epsilon r is nothing but relative permittivity. Now we can easily define relative permittivity, right? Relative permittivity can be defined in two ways. How you can define in two ways is, you can define it as ratio of electric force between two charged particles when they are kept at free space and dielectric medium, as well as you can also define it as a ratio of permittivity of a medium to the permittivity of a free space epsilon naught. So this is how, or these are the two ways by which or using which we can define the relative permittivity or dielectric constant. Clear? Now let us have a discussion on importance of Coulomb's law. What are the importance or what are the advantages of Coulomb's law? The forces exerted by two charges on each other are equal and opposite. Okay, we already have observed and understood that the forces exerted by two charges on each other are equal and opposite. Therefore, Coulomb's law agrees with the Newton's third law. Okay, so very simple meaning it is, if any charged particle is applying a force of 1 Newton on another charged particle, and then the same force will be experienced by the first charge because of the second charge. So that is what the meaning of force, that is what the meaning of this first importance, which is which is what the Coulomb's law follows the Newton's third law. Then second one, the forces act along the line joining the two charges, and hence these are all central forces. The force which are acting between two charged particles will be acting along the line joining the two charged particles. So this is the second importance of Coulomb's law. Now let us have limitations of Coulomb's law. Limitations or drawbacks of Coulomb's law we can have here. The law is applicable only for point charges at rest. Very important here, okay. This Coulomb's law is applicable only for point charges. What do you mean by point charges? Point charges is nothing but very small in size compared to its distance from other charged particles. So such charges we can call it as point charges. So their volume or area can be very, very negligible. So such type of charge we can call it as point charges. So here, so advantages of Coulomb's law is disadvantage of Coulomb's law is the law is only applicable for point charges, and another is only at rest. Coulomb's law ಯಾವಾಗ ಅಪ್ಲೈ ಆಗುತ್ತೆ ಅಂದರೆ Coulomb's law ಅಪ್ಲೈ ಆಗೋದು ಓನ್ಲಿ ಪಾಯಿಂಟ್ ಚಾರ್ಜಸ್ಗೆ ಮಾತ್ರ, ಮತ್ತು ಆ ಪಾಯಿಂಟ್ ಚಾರ್ಜು ರೆಸ್ಟಲ್ಲಿದ್ದಾಗ ಮಾತ್ರ ನಾವು Coulomb's lawನ ಅಪ್ಲೈ ಮಾಡಬಹುದು. ಇದು ಫಸ್ಟ್ ಡ್ರಾಬ್ಯಾಕ್. ದೆನ್ ನೆಕ್ಸ್ಟ್ ಡ್ರಾಬ್ಯಾಕ್ ಈಸ್ ಇಟ್ ಈಸ್ ಡಿಫಿಕಲ್ಟ್ ಟು ಇಂಪ್ಲಿಮೆಂಟ್ Coulomb's law ವೇರ್ ಚಾರ್ಜಸ್ ಆರ್ in arbitrary shape. In such cases, we cannot determine the distance between the charges. Then what is the meaning? The second drawback is we can apply Coulomb's law only to the bodies which are circular in shape or which are spherical in shape. If the shape of the charged body or particles not in a spherical shape, or if the shape is in arbitrary shape, different shape, then we cannot apply. ಯಾಕೆ ಅಪ್ಲೈ ಮಾಡೋಕ್ಕಾಗೋದಿಲ್ಲ? ಚಾರ್ಜ್ಡ್ ಬಾಡೀಸ್ ಶೇಪು ಡಿಫ್ರೆಂಟ್ ಶೇಪ್ ಆರ್ ಆರ್ಬಿಟ್ರಿ ಶೇಪ್ ಆಗಿದ್ದರೆ ನಮಗೆ ಎರಡು ಬಾಡಿ ಮಧ್ಯದಲ್ಲಿರುವಂಥ ಡಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಕ್ಕೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ವೈ ವಿ ಕೆನಾಟ್ ಅಪ್ಲೈ Coulomb's law easily to the charged body